Hi, my name's Seth Leger. I'm Vice President of Engineering at OpenNMS. Welcome to OUCE 2015. I hope everybody's excited to be here. And I'm going to talk today about a project that we've been working on for a little while called OpenNMS Minion. And has anybody here heard of Minion yet? If you've, yeah, I know that Taurus has blogged about it a little bit, and there have been some mentions of it in bug reports and on the discussed list. So it's out there. I Googled it the other day, and there's hits on Google, so it exists. One of the top 10, I think, was this talk, so you're in the right place to learn about it. Just as a summary, the Minion project is our effort to break up the OpenNMS app into smaller microservices so that they can be distributed to multiple machines. And this distributing the services is, the two basic goals are to increase the total scale of what OpenNMS can do, specifically data collection as an initial focus, and also to make managing networks or geographic locations that are widely separated more easy to manage. And I like to call that the reach of OpenNMS, like reaching into networks that are more isolated or possibly behind NAT or firewalls. So let's see. For the purpose of what we're going to talk about today, scale is, we're going to talk about data collection, the total amount of data points and metrics that we can collect on a specific interval. That's usually one of the key limiting factors in OpenNMS, and one of the basically the key feature that we wanted to address with the Minion architecture. So there is a finite limit to the amount of metrics you can collect with a single OpenNMS machine. If you reach that limit, then you can increase the number of threads in collect D, but this won't always solve the problem because you run into problems with thread contention. Even throwing more hardware at it won't solve the problem. So there's basically only two options you have in that case. You can reduce the total number of metrics that you're collecting, or you can add additional OpenNMS machines and distribute the load across them. When you run OpenNMS machines, when you run multiple machines, there are advantages and disadvantages to this approach. Starting up new OpenNMS machines it's a known quantity if you're already an expert with the system. Starting up a second system is easy to do, and you just have to partition the data collection evenly amongst each instance to get more scale. Each instance of OpenNMS also has full functionality, so they have completely separate data collection, polling, notifications. You can have separate user management if you wish, and they also have separate user interfaces. A lot of customers see this as an advantage because it's easy to separate roles for the users of the OpenNMS system. A lot of people will divide their OpenNMS machines on the area of expertise for the users. For instance, you may have one dedicated to your networking equipment, collecting metrics just from networking equipment, and another machine for storage equipment, and with different staff accessing each system. The problems with this approach, obviously, is you lose your single pane of glass view of your network. There's no way to see, a global view of what's going on. You also have a fairly complicated amount of configuration for each OpenNMS server. I mean, it's not something that you can do in your sleep. OpenNMS has a lot of customization that has to go into each instance that's brought up. And it has fairly high hardware maintenance and tuning requirements to get all the thread pools and everything running, running without issue. And with more machines comes, eventually you run into staffing costs to administer the number of servers that you have up. Another factor is scaling out this way is not a dynamic process at all. For each OpenNMS machine you bring up, you have to provision the hardware, install the software, perform the configuration, and then figure out for each circumstance how to divide the load amongst all the machines that you have. So with these disadvantages in mind, we want to provide a new tool that can make the process of scaling up OpenNMS's data collection easier. And our solution for this is OpenNMS Minion. And you might think, where did the Minion name come from? I'm not going to suggest that it had anything to do with some highly trademarked characters from Universal Pictures like Taurus was brave enough to do, so I'll keep this presentation safe from the lawyers. What does the name mean? We didn't really have any meaning in mind when we came up with it, but it could mini OpenNMS. I kind of like that one. Something more complicated, modular infrastructure for network instrumentation with open source niceties, like the GPL license, where a Faro GPL. But basically, the basic concept is that Minion is a helper for a central OpenNMS system. There's always a central OpenNMS system that's controlling the inventory and configuration for the cluster. So I mentioned earlier that we're dividing up OpenNMS into microservices that, so what does that mean? Basically a microservice, it's like a new name for something that maybe has been around for a long time. It's basically the idea that if you have a task to accomplish in any type of application, you should divide it up into very small bite-sized chunks that are that have a small footprint, basically in CPU, memory, and storage. They don't require a large monolithic system to run on. You should also make them a single process so that their life cycle is easy to control. They can be killed or restarted very easily from a command line or automated process. And you should make sure that each task has a single responsibility. That's the service that it's providing. Don't mix 10 concerns in the same process. Part of that has to do with the value on making a microservice stateless. Statelessness implies that there's basically no penalty for killing and restarting the service if it needs to be killed and restarted to, avoid a negative consequence or performance. And the last kind of defining factor for microservices, because they are small modular tasks that maybe run in clusters and are orchestrated with other microservices, they need to have well-defined inputs and outputs so that they're easy to chain together and coordinate with each other. So in our case, for the Minion architecture, we're using REST and JMS as those inputs and outputs, just standard interfaces, nothing, no binary streaming or anything like that. Let's see. So why did we pursue a microservice architecture? Well, basically because it's super trendy right now. Like everybody, you go to a conference, all you hear is Docker, Kubernetes, Docker, Kubernetes, Kubernetes. Actually, we don't really care about the trends. OpenNMS has been architected as a microservice really since the beginning. Internally, the different subsystems like provisioning discovery, link discovery, polling, data collection, and the event bus are all separate code bases that, while they have some common dependencies, they function basically independently already. The provisioning subsystem has its own set of thread pools that it uses when it's scanning. Collections the same way. It uses its own set of thread pools and configurations to accomplish all of its tasks. Like you can go into the service configuration and turn off collectee, and provisioning and discovery are unaffected. So the architecture lends itself to microservice architecture already. We've just never made the leap to making it into a multi-process service that has the statelessness and resilience that a true microservice would have. Another advantage of an architecture like this is the well-defined inputs and outputs. Because that's required for the processes to communicate with each other, it forces you to have a discipline about how cleanly your interfaces are designed. So it forces you to have higher quality and more well-documented interfaces. So yeah, once these subsystems are separated, we can use them to divide the workload and basically outsource data collection to Minion machines instead of handling all of the data collection on a single OpenNMS instance. So let's go over like why this is a little better than the current OpenNMS architecture. Well, the disadvantages I listed earlier were there's no single pane of glass if you have multiple OpenNMSs running. In the Minion case, we're using a central OpenNMS where the provisioning occurs, and it has a list of all the nodes and inventory and configuration. So you still have that one panel where you have access to all of the nodes that are being managed. And as far as configuration, I can't fit the OpenNMS configuration on any kind of slide. I looked at it the other day, and I think we have we're approaching 1 million lines of XML, I think, in our code.
Too much XML.
Yeah, if I hop to what does this say?
Number of code week or?
Oh. Yeah, it's, what have we got? Only 968,000 lines of XML, so that's not that bad. But the Minion configuration, you don't need to duplicate any of the data collection configs or go through anything like that. The data collection configs for Minion, it reuses the collection configuration from the central OpenNMS machine. And the data collection configuration is also done on the OpenNMS machine in the same way that it's done for the remote poller currently. Does anybody use the remote poller before? Well, the remote poller relies on having you define data collection, well, not data collection, polling ranges and configurations inside the OpenNMS poller config, and then you link them with the ID of the remote poller that they're associated with. So the same thing happens with Minion. You can assign polling and data collection packages to a specific Minion device. Another disadvantage we talked about was the footprint of OpenNMS is really large, so running multiples, you end up requiring a lot of hardware. I mean, basically the minimum for any type of install is about 8 gigs of RAM. You want as fast of storage as possible and a fair amount of it. You're definitely going to need like a lot of CPU power with a lot of threads to be able to churn through all the data collection and provisioning. And the tuning process for data collection and provisioning on the same machine is difficult in sometimes, especially since provisioning's a once a day task that may interrupt the continuous operation of the machine. And you have to deal with the database on the OpenNMS side somewhere. So that's a lot of complexity just to get extra scale out of the system for data collection. I mean, really, the Postgres database has nothing to do with data collection, but if you have to have 2 to double your scale, that's just more overhead. The Minion footprint that we're targeting is a much lower amount of RAM, closer to what we use for the remote poller, about 2 gigs. And storage on the remote poller is basically not a factor because it's used to load the image up, and the configs are then pulled from OpenNMS, data collection starts, but all of the data collection persistence is message-based. It just generates messages with the metrics and sends them somewhere. They're never persisted on disk unless there are network outages that prevent the transmission. So really, you need about 2 gigs for the software and probably not much more than that. Even a large amount of metrics won't take up more than a couple gigs, I would imagine. You'll still need a lot of CPU power, like preferably as many cores as you can get, because the message-based architecture of Minion, you basically have a message queue of tasks that it's going to process, and then it has a more limited number of threads that process these messages as quickly as possible. But the more you have, the faster the data collection is going to be. the thread pooling that we have in collectd is going to be a lot less necessary on the Minion side because it's message based. We can tune the thread pools more precisely because we know exactly how the messages are being processed at every step, instead of just having a larger kind of monolithic collection task that's running. And on the Minion side, because it's stateless, it doesn't store anything locally. There's no database. There's no like flat file system things that it's maintaining. Like I said, the only additional space would be if you lost network connectivity, you might have a JMS message queue that could back up. But so the idea here is we can run on a smaller, like I know Taurus mentioned today, Raspberry Pi sized machines. I'm not sure specifically about the Raspberry Pi. We haven't done any testing with it yet on ARM, but that's about the size, maybe instead of $20 machine, maybe a $100 machine could potentially be the lower end target for a Minion appliance. And if you want to containerize it further in with Docker or on a small virtual machine, that is definitely doable. The other thing I mentioned, there's no way to dynamically allocate OpenNMSs if you start running out of CPU or I/O on your machine. I guess you could potentially design a system like that where OpenNMS could monitor itself, and if its own load got too high, it could somehow provision additional management and divide the tasks up. But I put painful in the middle there for that because that sounds like something I wouldn't want to write or maintain. And it's a solution to a problem that you shouldn't have in the first place. So instead, you're much better off looking at Minion as a potential solution for dynamic scaling because it's based on a container already, so it's small footprint. It'll start up and shut down quickly. It's easy to wrap it in other standard containers like Docker. And the whole Docker container ecosystem already has tools for scaling, what they call elastic or dynamic scaling. So we should be able to basically use third-party tools for all of this concern and not have to work that into some OpenNMS clustering solution of our own. We just have to make sure that the Minion software can act in a cluster, which is maybe a future feature past the initial data collection goals that we've got. Let's see. So yeah, just to recap, what would be the advantages of using Minion with OpenNMS instead of spinning up multiple OpenNMSs to get better scale? Your configuration is easier and it's managed in one place on the central OpenNMS machine. There's low hardware costs with each additional Minion that you add. There should be much less tuning effort. It should be easier to monitor how many messages they're processing and how effective that is. And because there are third-party tools for elastic scaling, that is basically a possibility, whereas with OpenNMS today, it would be a very difficult, painful thing to implement. So the second concern I talked about earlier with large OpenNMS installations was just the ability to reach out into multiple locations and gather data potentially across remote network links that are not as reliable or have limited numbers of ports they can open to communicate. So our current solution for that type of management is the remote polar. How many people here have used the remote polar before? I guess I asked that already. Same people raise their hands. But yeah, the remote polar is kind of a specialized tool. It's easy to deploy. We have packages, we have RPMs, we have a jar installer that you can use on Windows. You can run it inside your browser using Java Web Start, like JNLP. So it's easy to run one. The advantage we listed for Minion, centrally managed config, that's true for the remote polar. They use the same type of strategy for the configuration. You work it into the polar configs, and then those polar configs are assigned to each remote polar system. They already have a small footprint because they don't do they don't do a lot of they don't do data collection or anything else heavyweight, and they report back answers as they get them, similar to the Minion architecture would. And they provide like an event-based polling mechanism. I say event-based because one of the disadvantages of the remote poller system is the event-based polling, while you can alert off of it, it doesn't produce outages like the normal polling process does on the OpenNMS side. So that means it doesn't support all of the path outage processing, and availability numbers and reports are difficult to generate because you don't get that data. Some other disadvantages of the remote poller, the way it is today, it's fairly difficult to expand what it does from what it does right now, which is polling. So it doesn't support data collection. Obviously, that's a big concern. I guess if we probably did a survey of most wanted features for the remote poller, data collection would be at the top. And the centralized management for it's pretty limited. Like you get pause and resume and start, stop, and you can, if you have everything geolocated, you can see the statuses on the map, but you don't really have an idea of what the performance is like of the remote poller, or, that kind of thing. So, let's see. So again, I think Minion is going to end up being an alternative to the remote poller in the ability to manage remote sites. Basically, all of the advantages that it has, it shares all the advantages of the remote poller. It's simple to deploy, centrally managed, small footprint. It's got a better architecture that's, module-based, so it's easy to extend, and it already supports data collection because that was our primary focus with Minion. The disadvantages versus the remote poller, it doesn't poll yet, so that's still in development. Basically, taking the existing OpenNMS poller code and refactoring it to be a Minion microservice. That's still in development. And also the centralized management piece of Minion, where we can do monitoring and lifecycle control, like being able to stop and start different Minions like from a central console. That's still under development too. And like Taurus mentioned today in the keynote, our code name for that is Dominion, which makes sense. But yeah, so we don't have the feature parity with the remote poller yet. Let's see. So yeah, just to recap, the remote poller is less easy to extend, but Minion is basically totally extensible due to its architecture. The event-based polling that the remote poller does, I think when Minion's polling microservice is done, it will basically provide the same features that the OpenNMS service did. Data collection, remote poller doesn't support it. It would be difficult to add because of the extensibility issues. And the reason that the extensibility is difficult on the remote poller because it's basically using like an RMI type design, which is you're shipping code to a remote system and then expecting it to talk that exact API back and forth. So every time you change the API, you have to reinstall the remote pollers, and it's just makes extending the model more difficult than using like a container where you can just throw modules and expect them to work statelessly. Yeah, the data collection now we have on Minion is SNMP and JMX, and we're planning on extending that. And yeah, the centralized management, we're in progress with Dominion, but we don't have feature parity there yet. So I would think once we do reach feature parity between Minion and the current remote poller, the remote poller is probably going to go away. There probably won't be any reason to use the remote poller code the way it is. I mean, the Minion code should be, because it's containerized, it should be easy to install on any type of system. I mean, say we packaged it as a Docker image you could download that's easy to run those even on Windows and Mac and Linux especially.
Would it still have the Java Web Start capability?
I don't know. Yeah, Java Web Start's kind of it seems to be kind of under fire lately. I know they keep restricting, you have to keep hitting OK on the please allow this to execute on my machine more and more in each version of Java. I know they put another level of that into Java 8. I don't think you can run unsigned code at all, no matter how many times you hit the please. Yeah. Yeah.
But also Chrome and Firefox these days have dispensed entirely with the NS API,
Yeah.
so you can't run it whatsoever.
Yeah. I mean, JNLP is definitely nice for just the quick being able to run things, but I guess the hope would be that the Minion code, the installation process should be very easy with the container architecture. I mean, what's the boot to Docker replacement they just released? I don't know, whatever it is. I looked at it the other day, and it's amazing. You get a whole control panel full of your apps. Let's see. So yeah, just our future plans for the Minion code. Obviously, add support for the remaining data collection protocols. We've got SNMP and JMX working, but yeah, there's more to do. HTTP, JDBC. All of these should be distributable to the Minion architecture, but really, actually, the SNMP collection and JMX collection are two different microservices. So each one of these is creating a new service that can process the different types of collections. Another bullet point here, this doesn't look like much, but add support for writing metrics directly from Minion into OUCE. That has the potential to, again, increase the scalability a lot, because in the current Minion architecture, we're communicating everything over messages, JMS, and there's still, the JMS is kind of a bottleneck in some ways, that it's a single point where all the data that's collected is going to flow. But if we support writing directly into a Cassandra cluster running OUCE from Minion, then we've completely decoupled the data collection from a single channel, because you'll be able to keep your inventory on OpenNMS and define your data collection configuration. Your minions will connect, download that, and begin collections, and they'll be writing directly into Cassandra. And the OpenNMS machine won't have to process replies, it won't have to do any data collection, but it will still be that single pane of glass talking to Cassandra for reads, so that you can generate graphs and reports off of that without having any of the load of the collection at all in the system. So this isn't a quantum leap to support, but we don't have it today. Maybe by the time, let's see. Yeah, one thing about the future development, we're working on Minion now, and we've targeted, I think our next development cycle for OpenNMS 18 will support Minion, but the way we've been working lately, we're more time boxed than feature boxed, so I'm not sure exactly which features will make it into the 18 release. I just know that Minion will have, a user interface, the data collection parts, and a Dominion management interface so that you can configure everything. But this basically what I'm saying, this might make it in if we have time to get it done. And then there's coming full circle, and the Minion data collection code provides basically an alternative path for collecting data with OpenNMS. So there's no need for collectd anymore, really. We'll probably get rid of collectd completely and just replace it with the Minion microservice running inside OpenNMS in standalone installs. So the code that used to be called collectd won't be there anymore, and it'll just be OpenNMS running on the same microservice that Minion does. So that's just something we have to do in the future. It's basically taking the old code, deriving a new microservice out of it, and then replacing the old code with a cleaner, more modern design. Let's see. We also have a lot more components left to convert into microservices. An obvious one for this, especially in reaching out to remote networks, is traps and syslogs. If you have traps and syslogs on a network, a remote network that's got poor network connectivity and you don't want to lose those traps and syslogs, an obvious feature is to add a microservice that can receive those on a Minion there, queue them up, and transmit them to OpenNMS as soon as possible when the network connection is reliable. Some work on that's already in progress. I don't think it's anywhere where you can actually build an RPM out of it yet, but it should be soon. And then the actual provisioning and discovery processes to fully distribute everything, we'll need to push those out at some point. And then to get feature parity with the remote polar, we'll need polling. But yeah, all that's on the roadmap.
Question regarding polling.
Mm-hmm.
This is, I haven't really mentioned it probably before, but with the remote polar currently, all your results will be locally timed given that that's where the actual code is executed on the remote polar.
Mm-hmm.
Would it be easy to adapt the functionality where you can trigger the poll from the central site to pass through the connection to the remote poll, make it execute it, and then report it back as a full distance poll? Is that a design case you thought of?
We have thought of that kind of as an artifact of laziness in some ways, because we that on-demand polling would be not laziness in terms of basically. Let me step back a little bit. A design like that, where you're doing on-demand polls from OpenNMS and basically executing the poll on the remote system and returning the results, that's maybe a first step in modularizing the polar. So yes, we have thought about that, definitely doing that as a feature of the polling subsystem, so that the poll could be initiated on the OpenNMS side, and the remote system is basically just doing the network operation and returning the results. That's definitely going to be part of the architecture. I think eventually, and I meant laziness as in that's the easiest thing to do for us actually, because the polar code on OpenNMS stays largely the same, like the scheduling and the calculating all of the path outages and things like that. It doesn't require us to forklift all of that code to the Minion side, which is much more difficult. So, but it's a progression. Like the first step, I think, is to leave a lot of the business logic on the OpenNMS side, just do the network operations remotely, and then. But I do think there's a lot of value in moving the business operations out to the Minion too, because you're distributing your CPU load out to the Minions, which can increase scale. And it gives them some degree of autonomy, so that if there are network problems between the Minion and the OpenNMS system, you're not going to lose data because of that. Like if you lost connection with the Minion and all of your scheduling's on the OpenNMS side, you're going to get blank polls, or the polls will never execute. You won't know what's going on. But. Mm-hmm. Mm-hmm.
And for some godforsaken reason, they're also running riverbeds. And when you do all the remote polling from the central site, they haven't decided what tools to use. They've gone for the let's do everything approach. So currently, most of the riverbed licensing is actually being eaten up by basically TCP polling for SNMP and stuff like that, instead of doing what the business is supposed to be doing.
Okay.
So if you then have a remote poll or a Minion with more or less a single connection to do all that through, that would certainly make for a lot of money.
Okay. Craig?
In terms of the overall model, one of the use cases for us is to put Minions in autonomous systems, which means they've got their own network topology and their own address space.
Mm-hmm.
How would that be supported within OpenNMS as a whole?
One of the scenarios is that, for instance, the branch office scenario where you have maybe 10 offices that have identical network systems and you want to collect the same data off of similar equipment. How do we keep that from, today it's you'd have to assign them different foreign IDs and keep all the data separate, but We've talked about, there are some, actually that's this point down here. We're working on some model changes to basically make location a kind of a key field in the nodes now, so that you can have nodes with overlapping address spaces that'll be represented better in OpenNMS, like
See, there'll be the links and the services are gonna have overlapping address spaces as well.
which links do you mean?
Link D.
Yeah. Yeah, the link D, I haven't really thought much about, we haven't really like sat down and spec'd out the link D, how it'll move to Minion yet. But I think, yeah, I don't know.
Adding a location ID is another dimension of node identity.
Yeah, definitely node identity. I'm not sure how that impacts like the link identity though, if it's, there might be issues there that we need to look at. Let's see, some other future plans. Right now, I've kind of talked about having, a cluster, say a cluster of minions attached to an OpenNMS that, where you're dividing the workload out between all three. More future development is just to have the minions orchestrate their own clustering, where you just say, oh, here's a queue of data collection that I want to occur in this location, and then have all minions in that location consume off that queue and coordinate with each other so that if one of them goes down, the other systems still consume off the queue and you're not losing, you don't ever have like a blackout in any location for data collection. If you have support for clustering, this gives you other things like high availability, the ability to like upgrade each minion and like with rolling updates where you can say, oh, I've got 5 in this location, take one down, upgrade it, take the next one down, upgrade it, take the next one down, upgrade it, while the data collection continues, so the upgrades are transparent. And then the elastic scaling I talked about earlier with where you have like a group of containers and we're using some third-party API to do scaling, that would enable us to expand a Minion cluster from 3 to 5 systems, for instance, and have them distribute the load evenly. Let's see. And we talked a little bit about support for overlapping address ranges. That's not really necessarily a Minion feature, but it's something that will make provisioning minions that have overlapping address spaces, it'll make the data more easy to comprehend on the OpenNMS side. Like for instance, you should be able to say, give me all outages in location A as seen from location B, which isn't possible in OpenNMS today. You just know that an outage was detected. You don't know, like for instance, if everything in location A is in the same data center, the machines there might not see an outage on a machine in the same data center, but if data center B can't reach data center A, then you get like a directional outage from one to the other. Let's see, what else is there to do? Oh, we actually should release Minion as part of 18. I mentioned that was on the roadmap. It's been under development for a while. We worked on the data collection microservice a lot last year in 2014. And it's been under test, like we integration test it, but we haven't really advertised it as a feature or given people, the RPM to use, but 18 will definitely have this as an additional feature. I think that's about all. Does anybody else have any more questions?
What state is it at the moment in terms of just downloading it and playing with it?
The RPMs are being built. I think we have one integration problem with the packages that makes it difficult to install that I was running into yesterday. It's basically like a ActiveMQ problem, but once we get that resolved, the RPMs are installable. There's a new user interface in OpenNMS 17 for defining monitoring locations and then defining minions that can be assigned to those locations. For anybody who's dealt with the remote polar, there used to be an XML file called the monitoring locations XML that had, it was basically like you would define a location however you wanted to define that, and you could geotag it and assign polling and collection packages that applied to that location. And then when you had a remote polar, you'd say, oh, associate this remote polar with location, Fulda. And that XML file is gone now. All that configuration's moved into database tables, so there's a new user interface for that. So yeah, for minions, you do the same. You still have to define a location and then define, let's see, put the minion in the database and then connect them together. But if we can work through this ActiveMQ problem, it should just be a matter of installing the RPM.
And ActiveMQ is separately installed, or is that part of?
Right now it's embedded just like Jetty would be inside the VM. So that's another new thing potentially going into 17. But the only thing we'll be using it for right now is the Minion communications.
What about provisioning from minions?
You mean, like how do they?
Like, say I want to provision a node that's reachable only from a minion.
True. The provisioning, let's see. Because, like I've said, we focused on data collection. Data collection is doesn't really rely on any provisioning information. Like it really just needs to know the IP address and what to collect off that IP address. So, but to do polling, we would need to have a way to associate a provision node with what's polling it to make sure that we're polling it from the correct minion. And that is also, that's another change we need to make to the node model. I think that's basically the same change necessary to support the overlapping address ranges. That change will not be, none of that will be in 17, but that's one of the changes we'll have to make for 18. Although that's only required if we're doing polling from the minions. So if Minion initially goes out as just a data collection engine, then that model change might not be in there. But yeah, to be able to poll things from the correct Minion device that you intended, we have to start making the location of a node part of the provisioning requisition.
And also, this has impact on outage. So an outage must refer to the location.
That's true.
So it's availability by location.
True. That's one thing that we can't do today because we don't associate outages with any particular location and that's because the remote polar, which is the only thing that does distributed polling,
Real outages.
yeah, it doesn't create real outage records. So
I changed the code for outages, if you remember, and now outages depends on events. So if you, it's not not so far.
Yeah, that's true. The events will also will be associated with the specific system that generated the event, which is also that was an intended feature of OpenNMS forever, that you would have multiple systems potentially creating events in the same database. It's never really been enforced. Like the remote poller does that, but we've never really cared about basically that origin field in the event. But now, yeah, we'll be using that to figure out from what location an outage was detected, for instance. So yeah, that's something to note, that a lot of the events always were tagged with what they called a distributed polar ID, but nothing referred to it, nothing used it. It was like a field to be used in the future. Well, this is the time when we start using it, when we start supporting true distributed events and outages. So yeah, all of those fields, actually there's something in the release notes now about OpenNMS 17 where you should clean out your event and alarm tables when you migrate, because there's a lot of database migrations that happen, and that's one of them. Is that I've renamed a lot of the fields to there's a monitoring location, which is like a position on the network from where you're monitoring things, and then there are monitoring systems in that location. So if you had 3 minions in a location, they would be associated with that location, and events that they generated would be associated with which particular minion generated the event. So yeah, that's a new kind of gradual change on the way to 18. So
Just because I can ask, is there any thought of integrating this view of basically distributed polling with the enhancement piece interpretation of a topology?
Kind of the same question.
yeah. I don't know. I need to talk with Antonio about that, because I don't.
I was basically figuring if you have many minions sitting around, let's say a very global architecture,
Mhm.
they all have their different views of what's out and what isn't out.
Yeah.
And then generate a coherent view of this part of your core is basically sucking packets at the moment. Something like that.
Yeah.
The approach that using a rules engine to detect widespread outages.
Yeah.
And I think Andreas was going to pull through and stuff with rules as well.
That would be. It sounds like we're talking about basically, if you had a network where everything could talk to everything else, and you did detect like widespread outages, like using that as a boundary for what we might call a location, or doing like heuristic analysis on what is next to each other. Yeah, that could be a feature. We've kind of envisioned so far that this would be more of a, you would lay out your minions in a particular place. But yeah, I could see something like that too. Oh. Do you guys have any more questions? Are you excited? Are you going to buy a bunch of Raspberry Pis when you get out of here?
Excited, yes. 500 pies, maybe.
Yeah, I got a little nervous when Taurus mentioned the Raspberry Pi this morning, because we haven't, I'm not sure if anybody in the world has ever run OpenNMS on ARM, and if you have, you should probably talk to us, but that'd be a cool thing to try. But I know they do have the ARM JDKs, like Oracle's got a nice JDK for it, but I'm not sure that anybody's ever actually run OpenNMS on a Raspberry Pi before.
If you go up one step to the Intel UCs,
Mm-hmm.
they're really handy for like up to a couple of hundred nodes.
Yeah.
We have one installed with just SSD and 16 gigs of RAM,
Mm-hmm.
and that's currently monitoring things like 350, 400 nodes, and it has absolutely no breathing problem whatsoever.
Yeah, and uses 8 watts or something, 5 watts.
It's literally the size of
Yeah, that's nice. I mean, I think that would be the, you know, the type of form factor we'd go for. The Minion stuff should be totally capable on that type of platform.
Actually, what you should probably be looking at is, can you run Minions on processors that are embedded in equipment or on blades?
Mm-hmm. Like as a,
So is it an offering that could be used by an equipment vendor built into the rack rather than?
yeah, like a firmware level, yeah. Yeah, that would be interesting. I mean, the fact that it's completely stateless and doesn't have any persistent storage would make it, you know, suitable for that kind of thing. Well, thanks for coming to the talk, and I hope you guys are excited about Minion and look for it in OpenNMS 18.